All right, let's take a look at lesson 6 from unit 7. So we're looking at areas in histograms, and we're going to find proportions of data in certain intervals. So here for the warm-up, we're going to find the shaded area between the function, the x-axis, and the boundaries x equals 1 and x equals 2. And then we're going to explain or show our reasoning. So we have the x-axis, which is here, and then we have x equals 1 and x equals 2. And then the function boundary is right there. Okay, so we know that we have a width of 1, right? And that's right there. And then if we were to cut off this triangle here, right at the height of 2, and take that and move it down, so take that whole thing and move it here, that would be about, I didn't do a very good job of drawing that. Move it about there. Then we would have a rectangle, still didn't do a great job. Then we would have a rectangle that has a height of 2. And again, that width was 1. All right, so the area is width times height, or 1 times 2, which is 2 square units. Remember, the area is always squared, and we don't really have a specific unit here, so we're just going to say square units. Okay, well, let's take a look at part 2. What proportion of the area between the function, the x-axis, and the boundaries 0 to 7 is shaded? So we already know how much is shaded, or the area of the shaded. So now we need the area of the entire function. And so let's try to figure this one out. So here we have, this is an area of 1/2, because that triangle, 1/2 base times height, the base is 1, the height is 1. This would give us, well, actually, you know what? We're gonna cut this thing up into rectangles and triangles. There we go. All right, so there's 1/2. Here's another 1/2. This is a 1 by 1. This is 1/2. If we swing that around there, that's going to be 1. That'll be 1. That's 1/2. And this is 2. And this is 2. No. That's 3. Those are 3. Sorry. 3, 3, and that's 3. So again, let's move that. And that was 2. So we have, we'll go from left to right. So we have 1/2 plus 2 plus 3 plus 1/2 plus 1 and 3 is 4 plus 3 plus 1/2 plus there's another 2 plus 1/2. All right, so we've got 4 halves. So that's 2 plus 2 is 4 plus 3 is 7 plus 4 is 11 plus 3 is 14 plus 2 is 16. So the whole thing is 16, and so the proportion is going to be the area 2 over the 16. So that's the part over the whole, the area of the part over the area of the whole. And so that simplifies to 1/8. So 1/8 of the whole is the shaded area. All right, let's take a look at part 2. A publisher takes submissions for short stories to include in a book. 200 stories are submitted, but the publisher needs to be aware of how long each story is. The way the publisher will put together the collection of stories, a page typically contains 200 words. The mean number of words for each story is 2,600, and the standard deviation is 400 words. And so we have a set of data that I'm just going to show you. You don't have to do anything with that. But what I have done is I've taken that whole set of data. So there are all the, let's see, how many, 200 stories. There's 200 stories and how many words are in each of those stories. All right, so the mean number of words is 2,600 and the standard deviation is 400. All right, so if a histogram is created using intervals of 200 words, what would be the area of the bar representing the number of stories that contain between 2,000 and 2,200 words? All right, so I made a list in Desmos of all of those numbers. I copied those numbers and made a list in Desmos. And then I made a histogram. And you can see how you can enter that into Desmos here. You just do capital L equals and then the straight bracket. And then you put in all of your data and then end that bracket. And it'll tell you how many pieces of data you have. So if you're missing one, you can easily tell. And then you're going to make a histogram using the list. And then that 200 means that's the width that we want our bars to be. And then the bar height is going to be the count. You could make it the relative frequency. So then it would be a proportion. And then we're not going to worry about density right now. And then I do my bin alignment to be the center. So I'm sorry, the left. So that way it starts at 1400. 1400 is not in the middle. Okay, so then I'm just going to make this smaller and then so we can see our notes a little bit better, but still see this bar graph or the histogram. All right, so we're looking at between, let's see, there we go. Let's mark this up. So we're looking between, it keeps doing that to me. There we go. Between 2,000 and 2,200. And so if you look at that, if you go across, I did not draw a very straight line. Let's see, that would be, each line would be 5. And that's a little more than halfway. So that's about 18. So 18 is the height. And then 200 is the width. And so that would give us 3,600. So that is the area of that bar would be 3,600 since there were 18 stories in that interval and the bar is 200 units wide. All right, what proportion of the total area is represented by that bar? And so we have a total area. Let's see. This would be well, actually, so if we were to, we don't even need to do that. We know we have 200 stories, and each bar is 200 units wide. So that would be 200 times 200 is the total area. So that would be 40,000. And so if we want that proportion, we are going to do 3,600 divided by 40,000. And if we put that in the calculator, we would get 0.09. So that would be the proportion of the total area. All right. So what proportion of the stories in this group contain between 2,000 and 2,200 words? And so there are 18 stories. And there are 200 stories total. And that would also give us 0.09. If we put that in the calculator. How does the proportion of the area you calculate relate to the proportion of stories in the group that contain between 2,000 and 2,200 words? They are the same. All right, what proportion of stories in this group are within 1 standard deviation of the mean number of words? Okay, and so the mean would be between, well, no, they tell us what the mean is. The mean number is 2,600. So the mean value is right here. And 1 standard deviation away from that, which was 400. So that would be 2,200 on one side. So that would be here. And then it would be 3,000 on the other side, right? Because you had your mean, which was 2,600, and this one was plus 400, and this was minus 400, okay? And so we're looking at what proportion are in between those. And let's see, we have 30 in this group. We have 39 in this group, 38 in this group, and 30 in that group. And so when we add them all up, let's see, we get 137. So we have 137 out of a total of 200 stories, right? And then if we put that in the calculator, we get 0.685. Now we're looking at within 2 standard deviations. So let's come back to our histogram. Actually, let's undo that. Oops. I don't know if I can get rid of that. I want to do my, there we go. Okay. So now we're looking at in between 2 standard deviations. So that's 800 on either side. So 2,600 minus 800 would be 1,800, which would be right here. And then 2,600 plus 1,800 would be 3,400, which would be right there. Okay. And so then here we had 18, and here we have 9. And then on this side, we have 19 and 9 again. And so this total is going to be 192. And let's see. So 192 out of a total of 200 is going to be 0.96. So 68.5% of the stories are within 1 standard deviation, and then 96% of the data are within 2 standard deviations. All right, so then it says what proportion of stories in this group are within 1 standard deviation of 2,400 words. All right, so we're looking at 2,400 words, and we are going to erase that and that and that. All right, and we are looking at, so 2,400 is right here, and then 1 standard deviation is 400 away. So we're looking at 2,000 and then 2,800, which would be right here. So we're adding these values. And so that's going to give us 125. So that's 125 out of 200. And that gives us 0.625. So 62.5% are within 1 standard deviation of 2,400. Okay, so we're done with that histogram. Let's take a look at part 3. A company collects data from 10,000 websites about how long it takes to load the site. The number of seconds it takes to fully load the website is summarized in the relative frequency table. So now we have a relative frequency table instead of just a count of for each bar, we have relative frequency. So that kind of gives us the proportion there, depending on how wide each bar is. But anyway, so we've got our relative frequency histogram. You can see all of the data on the left-hand side. All right, so we know that the mean is 3 seconds and the standard deviation is 0.4 seconds. So would a normal distribution be a good model for this distribution? And it looks like when you follow this, you join all of those corners. It's kind of hard to see on this side. It does look pretty normal. Sorry about the dog barking. Yeah, a normal distribution is good because the data is symmetric and it's bell-shaped. All right, what proportion of websites loaded within 1 standard deviation of the mean? All right, so remember the mean was 3 and a standard deviation was 0.4. So here's the mean. And a standard deviation is 0.4. So we're looking at that interval, right? And so we have 2.6, so that's 0.1555. Actually, I'll write it down below. All right, so we've got this one, this one, this one, and this one. Let's see. I'm not going to remember those. All right, there we go. So we have 0.1555 plus 0.1861 plus 0.1938 plus 0.1447. And so that equals, if you use a calculator, that's going to equal 0.6801. So between 1 standard deviation on either side, it's about 68% of the data. All right, what about 2 standard deviations? So now we're going to 3.8 and 2.2. So now we need those 2 and those 2. So I'm going to make it a little bit easier here, and we're going to take that 0.6801 because we've already done that, and we're going to add 0.442. I'm not sure if I said that right. It's 0.0442. 0.0910. All right, and then we had 0.0923. And finally, 0.0447. And when we add all of those up, we get 0.9523. So about 95%, a little bit more, of the data are in between 2 standard deviations of the mean, or within 2 standard deviations of the mean. All right, and then what proportion are within 1 standard deviation of 2.8 seconds? So let's get rid of this. Now we're looking at 2.8 seconds and 2 standard deviations. So we're going from 2.4 to 3.2. So 2.4 to 3.2. And so that's 0.0910. Let's see. There we go. All right. So 0.0910 plus 0.1555 plus 0.1861 plus 0.1938. And that is going to equal 0.6264. If we use a calculator, we can get that pretty easily. All right. Then we're going to compare the proportion of websites within 1 standard deviation of the mean to the proportion of stories, that was in the last part, in the submissions that were within 1 standard deviation of the mean. And then do the same for the proportion with 2 standard deviations. All right, so 1 standard deviation. So within 1 standard deviation. Oops. For the websites, we had 0.6801. And then for the stories, which was also a normal curve, let's see, one standard deviation, we had 0.685. So 0.685. Those are pretty close. They're both about 68%. And then within 2 standard deviations, for the websites, we had 0.9523. And then for the stories, we had 0.96. So they're both pretty close to 95 or 96% of the data. So that's pretty close. So this one's about 68 or 69%. And this one is about 95 or 96%. All right, and then you can take a look at the summary. We have a normal distribution, and the key takeaways, I think, are there will always be about 68% of the data in a normal curve that is within 1 standard deviation, and then within 2 standard deviations, it's going to be 95%. Really, down here this is a key statement to know. If you take statistics, this is going to come up a lot. So within 1 standard deviation of the mean on both sides, you'll have 68% of your data. Within 2 standard deviations, you'll have 95% of the data, and more than 99% of the data is going to be in between 3 standard deviations away from the mean. So if you have something that's more than 3 standard deviations away, that is an outlier, and that is not normal.